All right, so in this video, we're going to discuss ratios. So we're going to talk about what a ratio is and how we can solve for ratios and how we can set them up. So our enduring understanding, so what you are going to learn in this video is you will be able to write a ratio to compare two quantities, and you'll also be able to use a ratio to solve for problems, and then we'll also be able to use a ratio to compare two or more quantities. All right, so we're going to work and do problems using ratios. So you might ask yourself, what is a ratio? Well, a ratio is a comparison of two quantities by division. So a ratio is comparison of two quantities by division. We're going to learn later on, though, that we can actually do this when we have more than two quantities as well. But we can write a ratio using any number a and b, where b cannot equal to 0. And we can write it three ways. So we can write it as a fraction, where a is our numerator and b is in our denominator. And this is why b cannot equal to 0, because remember, you cannot divide by 0. It's undefined. We can write it as a colon b or a to b. In all these cases, we are comparing how many of the a's we have to our b's. So if I say the ratio of length to width is 5 to 2, length to width, that means that this will be written as 5 over 2, 5 2, or colon 2, or 5 to 2. All right, so it's telling us we're comparing A to how many B's we have. All right, we usually will express these in the same units. So in some questions, you might have to convert units. Now, since you guys do not use since you guys aren't familiar with the U.S. system, I will always provide for you how many inches are in a foot, how many feet are in a yard, and so on. But one of the things you have to make sure that you remember to do is when you write a ratio, it must be in simplest form. All right, so you must simplify. That's why this is the way that I will typically ask for you guys to write your ratios. So this way you know, and it jumps out a little bit easier for you as to how to simplify, because you're used to simplifying fractions, whereas you might not be used to simplifying when it's in these two forms. All right, so let's go over an example. So this is just a really basic, easy example, just going over setting up a ratio. So a farmer has 20 oranges for sale and 15 apples. Write a ratio of how many apples to oranges the farmer has. So that means it needs to be A colon O, A to O, or A over O, because we are comparing how many apples we have to our oranges. All right, now, the way that I'm going to suggest that you write this is the fraction, because then remember, we always have to write ratios in simplified form. So we have 15 apples, so since apples was in our numerator, it will be 15 over. And then we have 20 oranges, so it was apples to oranges, so our oranges need to go in our denominator, so it's 15 over 20, and then you reduce. Well, we know 5 goes into 15, so we can divide 15 by 5, and that goes into it 3 times, and we can divide 20 by 5. That's our common multiple that each number can be divided by. So our final answer for this will be 3 over 4. All right, so remember, when you're writing your ratio, you must simplify. So the ratio that we have of apples to oranges is 3 to 4. So that means for every 3 apples we have 4 oranges. All right, so the next example that we're going to do, I was showing you for a reason doing this, and it's because we're going to do the opposite of this. So when we were doing ratios, remember, we always simplify. So we always say which number goes evenly into both of our numerator and denominator, and we divide each of those numbers out by that. So in some cases, we're going to have to do the reverse of it. So let's look at this problem. So members of the school band are buying pots of tulips and pots of daffodils to sell at their fundraisers. They plan to buy 120 pots of flowers. The ratio of number of tulips to number of daffodils will be 2 to 3. How many pots of each type of flower should they buy? So remember, this ratio of 2 over 3 is its simplified form. So that means if we want to get to the real number of tulips that they had and real number of daffodils that they had, we would have to multiply each of these numbers by some variable. And I'm just going to say x. So I'm going to erase this real quick. I'm going to that for multiplication. And if I multiply that 2 by that number x and 3 by that number x, that will bring us back to our original value that we had before we reduce. Because if we look back at this example, we divided each number by our common multiple. Well, if we want to get back to the original, so from 3 to 4, if I want to get back to the original, since we divided each one by 5, if we multiply each one by 5, we will get back to the original 15 over 20. So for this problem, since this is reduced, since that's reduced, we need to figure out, well, what number did we reduce it by? So that means we need to multiply each number by some variable x and the same variable to represent what we reduced it by. All right, so now we know that our tulips can be represented by 2x. So the number of tulips we have, number of tulips, is equal to 2x, and then the number of daffodils is equal to 3x. So if I want to solve for what x is equal to, well, I know I have a total of 120 flowers. So 2x plus 3x is equal to 120. Because I know however many types of tulips I have and however many daffodils I have, that will add up to 120. And then I solve this equation. So 2x plus 3x is 5x, and then I divide each side by 5. So that means that x is equal to 24. All right, so that told me what I reduced each one by. So if I want to find the number of pots I need of each one, I need to then plug x in both of these equations. So then the number of tulips, will be equal to 2 times 24, which is equal to 48. So that means we have to have 48 tulips. And then the number of daffodils is equal to 3 times 24, which is equal to 72. So that means we had to have 72 pots of daffodils. All right, so that is solving for problems of ratios. Now, remember, ratios are where we do have two quantities, but we can extend this and go for more than 2 as well. And when we do that, when we look at more than 2 ratios, or more than 2 quantities, it is called an extended ratio. So an extended ratio compares 3 or more numbers. Sorry, I didn't write that. So extended ratios compare 3 or more numbers. So a regular ratio is just comparing 2 numbers, but we don't stop at that. We can compare more, and it's called an extended ratio. So in this case, an extended ratio A to B to C, the first ratio of the 2 numbers A to B is the same ratio as the last 2. So whatever A and B simplify to, so A over B, this will be equal to B over C. And this will also be equal to A over C. So whatever ratios we can create, whatever combination we can create of those A to B to C are all equal. All right, and remember, I put A in the numerator and B in the denominator because we're doing A to B. I put B in the numerator because it's B to C, so it's B to C. And I put A in the numerator because since A is to B as B is to C, that means A would go to C. So they're all written in that order specifically because of the way that they're written here. All right, and then there's one more question that we're going to do, and this is it for this video. So now we're going to do a problem for extended ratio. So it says the lengths of the side of a triangle and the extended ratio are 3 to 5 to 6. The perimeter ratio is 98 inches. What is the length of the longest side? So first, let's draw a triangle, and let's fill it in. 3, 5, and 6. Now, this does not represent what the actual side lengths are. This ratio is simplified as much as we can. So remember, when we simplify, we divide by some number. So each of these need to be multiplied by that same number. So we can find out the true sides of the triangle by undoing our ratio or by unsimplifying our fractions. And since we all divided by the same number, we would just multiply them all by the same number. All right, and remember, a perimeter of a triangle is where you add up all the sides. So I know 3x plus 5x plus 6x is equal to 98, because that's the perimeter of the triangle, and I know when I'm solving for the perimeter, I add up all the sides. So 3x plus 5x is 8x, 8x plus 6x is 14x, is equal to 98. And then you divide each side by 14. So x is then equal to 7. So that means what we reduce each side by to get to this ratio 3 to 5 to 6 is we reduce each number by 7. but it only asks us not to find what we reduce each side, but it says what is the longest side. But since 6 is the largest number, is 3, 5, and 6, we know all we had to do to solve for the largest side is 6 times 7, because we need to plug in 7 for x, and 6 times 7 is 42. So that means the largest side of this triangle is 42 inches. All right, that is it for this video. One more for this section, and then we're done with this section.